Good day, everyone. My name is Maria Sofia M. Amado, and I am here to discuss with you my topic about periodic trends in metallic properties in alkali metals. Before I proceed to my topic, do you have any idea what alkali metal is? So, in this lesson, you will learn about what alkali metal is, and you will also learn about their properties and trends in their reactivities. The alkali metals is found in the first column of the periodic table, which include lithium, sodium, potassium, rubidium, cesium, and francium. Among the alkali metals, sodium and potassium are abundant, and lithium, rubidium, cesium are much lower abundances. Francium is extremely rare. Because of this, its chemical and physical properties are not known. Francium is the least electronegative of all the known elements. And next is the alkali metals properties. These metals have a body-centered crystal structure with low packing efficiency. They are also known because their low melting point and soft enough to be sliced with a knife. The lightest known metal is lithium and has a great chemical reactivity. Lithium never occur naturally in elemental form, and they are found with halide, sulfate, carbonate, and silicate ions. And this is the other properties of alkali metals. As you can see at the table, the alkali metals all have 1 electrons in their outer shells. The alkali metals is generally become more dense down the group. But the trend is not perfect because potassium is less dense than sodium. As you go down the group, the elements become more reactive. Another trend as you go down the group is that the melting point at the boiling point decrease. The alkali metals have largest atomic radius in their periods, low ionization energies, and low electronegativities. Sodium and potassium. Electrolysis is the process where metallic sodium is ideally obtained from molten sodium chloride. This compound sodium chloride has a high melting point at 801 degrees Celsius, where much energy is needed to keep large amount of the substance molten. Addition of calcium chloride can lower the melting point to about 600 degrees Celsius, which is an ideal temperature for the electrolysis process. Metallic potassium is soluble to molten potassium chloride. That's why it cannot be prepared easily by the electrolysis process. Moreover, it vaporizes readily at operating temperatures, creating hazardous conditions. Instead, it is usually obtained by the distillations for molten potassium chloride in the presence of sodium vapor at 892 degrees Celsius. And this is the reaction takes place at this temperature. Sodium peroxide reacts with water to give an alkaline solution and hydrogen peroxide. Like sodium, potassium forms the peroxide. Potassium also forms the superoxide when it burns in air. Sodium chloride. Sodium chloride, also called table salt, is a typical ionic compound, a brittle solid with a high melting point at 801 degrees Celsius that conducts electricity in the molten state and in aqueous solution. Rock salt is one source of sodium chloride which can be found in subterranean deposits where often hundreds of meters deep. It is also obtained seawater or brine, a sodium concentrated sodium chloride by solar evaporation. Sodium chloride also occur in nature as the mineral halite. Sodium carbonate. Sodium carbonate, also called soda ash, is used in all kinds of industrial processes, including water treatment and the manufacture of soaps, detergents, medicines, and food additives. For many years, sodium carbonate was produced by the Solvay process, named after Ernest Solvay, a Belgian chemist, in which ammonia is first dissolved in a saturated solution of sodium chloride. Bubbling carbon dioxide into the solution result in the precipitation of sodium bicarbonate as follows. Sodium bicarbonate is then separated from the solution and heated to give sodium carbonate. Sodium hydroxide and potassium hydroxide. Sodium hydroxide and potassium hydroxide has a similar properties, are prepared by the electrolysis of aqueous, sodium chloride, and potassium chloride. Both hydroxides are strong bases and very soluble in water. Sodium hydroxides is used in the manufacture of soap and many organic and inorganic compounds. Potassium hydroxide is used as an electrolyte in some storage batteries, and aqueous potassium hydroxide is used to remove carbon dioxide and sulfur dioxide from air. Sodium nitrate and potassium nitrate. Sodium nitrate decomposes with the evolution of oxygen at about 500 degrees Celsius. Potassium nitrate is prepared beginning with the reaction. In summary, the alkaline metals are the group 1 metals. They react with water to produce hydrogen gas and their corresponding metal hydroxide. Moving down the group softness of the metal increases reactivity with water increases.